So, Naveen, are you there?
Yes, sir.
Okay, so I think we should start now. It's already 10:30.
Yes,
So,
sir.
okay, there is one user who has joined, one participant, Nivid, Nivid Chandra. Nivid? Hello, Nivid. You can unmute. Can Naveen, you can unmute Nivid. He can ask
Okay.
questions if you.
Okay.
Nivid,
Okay, sir.
Nivid, you can ask any clarification doubts if we have. We can discuss.
Okay, sir.
Do you have any specific doubts, specific clarifications?
Don't have too many doubts, sir.
Ask what are the doubts you have. You can ask one by one. Whatever
Uh,
is possible, we will discuss.
One question is, sir, how we determine I for different isotopes?
I spin.
It's been.
See, remember in one of the earlier class itself, I told you very first class, it depends upon atomic number and atomic weight. Okay, depending upon, for example, if both atomic number
Yeah,
and
that I
atomic
understand.
weight
Yeah.
are even number. Okay. For example, carbon 12. In the case of carbon 12, atomic number of carbon is 6, atomic weight is 12, both are even numbers. Then I is equal to 0. Such nuclei are NMR silent nuclei. Whereas if one of them is odd, let us say proton, take hydrogen atom, atomic number is odd, atomic weight is odd, both are odd. In such case, it can be whatever may be the atomic number, atomic weight should be odd number. For example, proton, atomic weight is odd, atomic number is odd. Carbon 13, atomic weight is odd number. Such nuclei will have what are called spin half. I is equal to half. You have to decide based on the atomic number and atomic weight of the corresponding isotope.
Okay, sir.
Is it clear for you?
Yes, it's clear. It was, it is clear.
You can be louder. I'm not able to hear you.
Other question, sir, is that this B1 is we know that the spectrometers work in the megahertz range. Okay.
Correct.
But for a nuclei, this axis of chemical shift generally comes into around 1000 hertz or something.
Correct. Correct.
So for a new nuclei can come anywhere in this megahertz range.
Correct.
So how do you look at? I take for example, you taught us that the resonating frequencies of 119 tin and 117 tin differ by 8.3 megahertz and a 500 megahertz spectrometer.
Correct.
Now 8.83 megahertz is a very large scale. So
Correct.
how do we locate this small tiny window of 1000 hertz, 1000? Do we keep going and
No, let me answer you. What is happening is tin 119 isotope and tin 117 isotopes, they are two different nuclei.
Yes.
Okay. So, and we know the resonating frequency of tin 119 is at a particular megahertz frequency. And tin 117 is also at megahertz, but each of them differ by 8.3 megahertz. That's what I told you, no? So when you're detecting tin 119, you have to detect independently. Tin 119 and tin 117, they are two different nuclei. Because your spectral range of coverage is of the order of few kilohertz, 10, 20 or 30, 50 kilohertz. So you cannot cover such a wide range of frequency. So that is the advantage. You go to tin 119 frequency, get all the spectrum corresponding to tin 119. If you want to see tin 117, then you have to move the resonating frequency. Completely, you have to move it to a different frequency, like you do for proton and carbon, to a different frequency. You have to move far away, and then you start looking at the resonance.
But what happens when we do it for the first time? When we don't have any idea where it will come?
No problem, sir. It is easy. You will always have the resonating frequency in a given magnetic field. You know that. And you can tune what is called probe tuning. You can tune the probe for a particular resonating frequency. And from that place, from that frequency, you can cover the wide range of 10 kilohertz or 20 kilohertz to see your peaks.
Okay. So
You got the point?
okay. So first probe tuning is done, and then
Exactly. For a particular frequency, you have to tune the probe. You will go to that frequency of a nuclei. And then spectral width is there that covers a wide range of chemical shifts which correspond to that resonating frequency of a nuclei. Over a small range, you can cover.
other term is, sir, you are calling J as scalar coupling. Does it mean there are some other types of coupling also?
Yes. In fact, I did not discuss in this. In the earlier classes, in the previous course, I said, we have what is called a dipolar coupling. Meaning, this coupling need not be through covalent bond. This coupling can take place through space also. As I told you, each nuclear spin is a magnet. I can bring two magnets close in space. Then one magnet will disturb the other magnet nearby. And there is no need of a covalent bond. This type of interaction is called a through space interaction, and it is called dipolar coupling. That is dependent on the orientation of the vector. That is not scalar. You understand?
Okay.
And also we have one more coupling called quadrupolar coupling. That is for the spin greater than half nuclei. I did not discuss this in this course because this is mainly we were concentrating on spin half nuclei. So there are other couplings also apart from scalar coupling.
Okay, sir.
You got the point?
Okay, sir. Yeah, in 2D COSY, I have seen that there are phase, but
Yeah, you have to be louder. Can you increase the volume of your mic?
Okay, let me see.
Or come close to your mic and speak.
Okay. Yeah, sir.
Yeah.
We had seen this contour plots in 2D, right?
Mm.
But we have not made use of any of these contours in any of this 2D COSY or TOXY.
No. We have been using
interior structure of the interior structure of the contour. Interior structure, how the contour looks like.
Remember, what is your question? If I have to understand clearly, you want to know how does the contour comes, is it?
No, contour comes, I have understood from your analogy of the mountain.
Correct. Yes.
What I can see, this you have not made use of any of this interior feature of the contour in the COSY. I mean, the structure of the contour itself is not being made use of.
No. Contour structure, you don't have to worry. Contour is nothing but a peak.
Yes.
Center of the contour to center of the contour you measure, then you are measuring the particular parameter. You don't have to worry about how the contours are there within a contour. Like several contours could be there. You don't worry about the structure of the contours.
Okay. So we don't need, we just need to locate the center of the contour.
Exactly. From that, you have to measure any other parameter correspond to another contour from that center.
Okay, sir.
Is it clear for you?
Yeah. Sir, one question is very practical type. I asked this broker company for a small, for the price of the NMR. They did not give us. They could.
See, the price of NMR, what can I tell you?
A small NMR for a state university like us, which is cheapest NMR will, I think, will be good enough.
You want to buy the equipment?
So I am not going to buy. I am not in a position to buy, but just want to know in case we in future we want to buy. How will
okay. See, what I can suggest is, Nivid, I can suggest you one thing. There are various frequency spectrometers available. Starting from nowadays, nobody uses 100, 200 megahertz. That is all gone. Minimum they use 300 megahertz or even 400 minimum. And you can go up to 1 megahertz. 1 gigahertz like that, depending upon your need. For 400 megahertz spectrometer, approximately it will cost about 2 to 3 crores, depending upon what are the things you buy. It is like buying a car. You can buy a body and a wheel, but then they keep adding for accessories, varieties of things. Like that, basic cost may be about 2 to 3 crores. Then depending upon probes, how many probes you buy, and what are the features you have, how many channels, like that, cost will vary. So I will ask broker people to contact you if you want.
Okay, sir.
The cost depends upon the company's perspective. I cannot tell you what is the cost of the equipment.
Nivid,
Yes, sir.
just we have bought one 400 megahertz with basic specifications. That is 300,000 US dollar.
Oh, very good. That is about 2.4 crores,
2.4 crores.
Very good.
Whatever we have many things into that included, two channel probe, two channel amplifiers, and it is like it is for basic need, it is sufficient.
Correct.
And just we are getting delivery this month end, that is 300,000 US dollar.
Oh, very good. So you got the idea now?
Yeah. Cheaper NMRs are no more available. This 200 mega.
Not less than that you cannot get. I don't think so, because
They
it is
are all gone nowadays. Nobody uses 100 megahertz, 200 megahertz.
so for that you can look for the desktop NMR. Broker is also selling. That is a maintenance less. That is a permanent magnet, 80 megahertz, and you can get whatever you need, like not very advanced experiment, but the basic experiment, everything you can do, even this 2D, 1D, many nucleus, and that will come within crore.
Correct. See, you can consult Sandeep.
Acha.
Sandeep is here, In fact, he has several spectrometers with him in his group. You can ask Sandeep. He will give you more information. You can send him an email. Sandeep, you can share your email to him. He can contact you if he requests.
I will share on group only.
I think I took your email, sir, last time.
Last time I gave my email ID.
So you can ask him whatever the information about equipment. Otherwise, he will put you under concerned person in broker or Geo. You can contact them. Anybody else? Maybe any other question? And there is another person, Nilesh Rahate. Nilesh? Hello, Nilesh. Are you hearing me? You can unmute and ask questions. Okay, Nilesh is not asking anything. Nilesh, tell me please. Yeah, Nilesh, tell me.
I want to ask a question related to APT.
Okay.
I am confused. Somewhere I have read in APT for odd number of hydrogens on carbon, there is negative peak. Somewhere I read it is positive peak for the number of odd hydrogens on carbon.
It's okay.
So how we detect clear this concept?
I tell you one thing. Sandeep, you would like to say, or shall I answer?
You continue, sir.
Okay.
You can explain.
Okay. See, Nilesh, APT is called attached proton test. It tells you, it identifies carbons which are attached to odd number of protons to that of the carbons attached to even number of protons or zero protons.
Yes.
That means CH and CH3 can be identified from quaternary carbons and CH2 carbons.
Right.
In one important thing you must remember, the phases between these two peaks are opposite. What does it mean? If I make CH and CH3 positive, CH2 is negative.
Right.
If I make CH and CH3 negative, CH2 is positive. It is the relative intensity is what is you have to worry. You understand?
Okay.
Which is positive, which is negative, it is your normally convention is CH3 and CH3s are always positive, CH2 is negative. That is the convention followed in every books. But You can do the phase correction opposite way also. You can make CH and CH3 both negative, CH2 positive also. That is only your convention. But you must remember, one is a positive intensity peak, other is a negative intensity peak. That's all you have to remember. To distinguish between carbons attached to odd protons and even protons.
Okay.
And between CH and CH3, there is no way you can distinguish.
Okay.
For that, you have to go to what is called depth experiment. I think I have already discussed depth. I don't know whether you have understood that. I have
Yes.
that you have to understand by depth.
Okay, sir.
Is it clear?
Yes, sir. Right.
You have any other questions? Any other doubts?
I want to know about good reference book for 2D NMR spectra.
2D NMR spectra. Okay. I can share some of the important books what I have, but there is one book by yesterday I said that Neil Jacobson book you can read.
Okay, Neil Jacobson.
Yeah, Neil Jacobson book. Freibolin book is also there. That's also very good. For interpretation alone, if you want to understand, there is another book and by, I forgot the name. I can send you by email.
Okay,
I don't
sir.
remember offhand. I can send you by email.
But how do you know about my email, sir?
You have to share it here, you know.
No, we will share on NPTEL mail.
Okay, you do one thing. You please get in touch with Sandeep. He can say give you the idea about all possible good books which you can try to buy it or download it if it's available free.
But how to contact Sandeep, sir?
Sandeep is giving you his email right now here.
Okay.
You can note it down. On the chat box, he's going to write his email.
Okay, sir.
You can write down his email and be in touch with Sandeep.
Okay, sir.
You have my email ID also, you know. In every class in the first slide, I will show that.
Okay, okay. Sir.
You can
write
get
to
it
me.
in chat. I have just sent.
Yeah, he has already sent it. You can note down or you can write to me or him, one of us, no problem.
Okay, sir. And for combined structural problems, sir, same book we can use?
What combined structure means? I don't understand what you are telling.
Like you have to use data from UV, IR, NMR, mass.
Yes.
And then you have to interpret the problem, that structural problem.
There is one book on that. Several books, not one, several books are there. Interpretation of spectral data interpretation. There is a book. I'll 1 second be on the line. I'll show you that.
Okay.
Okay, it is called NMR data interpretation. That is one book. Okay, there is one book by name Organic Structure from 2D NMR Spectra. Write down.
Okay, organic
structures from 2D NMR spectra.
From 2D NMR spectra.
That is by Leslie Field, LD Field, and other two authors are there. 3 authors are there. By name LD Field. He gives a lot of solutions for many of the chosen problems. He has about 60 or 70 structures solved in that.
Okay.
You can read that.
Right. Thank you.
Okay. And a few other books are there. When you write to me, I will find out. Offhand, I cannot remember, but I can write to you.
Right. Thank you. Okay, thank you.
Okay. Any other question you have, Nilesh?
No, not. I will ask on email ID, sir, in future if I am cross.
Always, you can always ask anything. So, only thing is give us 1 or 2 days time to respond.
Okay. Thank you, sir.
Nivid, anything else?
Yeah, I also need some help regarding books. I am more interested in protein NMR. So I think I've seen this book cover nights. Very heavy book actually. So
That is a Kavanagh book, is 5 authors book. That's very good for protein structure. He
Yeah, but-
also covers lot of theory of NMR.
Acha.
You should have some knowledge about physics of NMR. That is very good. Then you can understand physics, chemistry, biology, everything from that book. It is one of the best books I can say.
but it is slightly heavy. So is it a lighter book? I mean, much easier to read.
Okay,
Basics.
there are several books here. I'll give me 1 minute time. Give me right now, I'll tell you. See, there are lots of books I have. In fact, NMR spectroscopy simplified and explained is there. NMR spectroscopy in organic chemistry, NMR spectroscopy in food chemistry. Varieties of books are there. And NMR in pharma chemistry is there. Drug development is there. I think it is difficult to tell you everything. Okay, right now. You can see Claridge book also is there. That's also very good. For protein, I don't have anything with me at the moment except the Kavanagh book. Kavanagh is the only good book for protein that I have a copy. Also, there is NMR spectroscopy of biological solids. There is one book by Govil and Professor Chari. You can see that book also. Okay. I'll do one thing. Right now, it may be difficult to identify and tell you. Send the email to us. I will write to you.
Okay, sir.
What are the important books I have? Maybe 1 or 2 I have soft copy also. I can share it with you.
Okay, sir. That will be great. Actually, I'm not an NMR practitioner of protein NMR. Just want to read out of curiosity.
I understand. I understand your interest.
So,
Kavanagh is the best book, I would tell you.
But it's little heavy. I mean, I could see that second edition is very big.
There is also a book by Utridge that is very good on protein NMR and everything.
He got Nobel Prize for that. Yeah.
Utridge book is there. You can see that also. That is pretty. I don't know whether he has the latest version. Some pretty old version book is there by Utridge.
Yeah.
You can see that. But I don't have a copy of Utridge book, but I have a copy of Kavanagh book. I can share it with you.
Okay, sir. So can I leave?
Whatever you would want. If you don't have any questions, you are free to leave anytime.
Okay, sir. Thank you. Thank you so much, sir. Thank you.
Okay, sir. Thank you. I am also leaving. Thank you.
Okay, Nilesh. Thank you. So anybody else? Nobody, no other participants are there? All right. Okay, Naveen. Naveen, are you there?
Yes, sir. Yes, sir.
So what do we do now? So all the participants are not, they have logged out. There is nobody. Shall we put an end to it?
Yes, sir. We can wind up, sir.
We can wind up?
Yes, sir.
Okay. Okay. Thank you, Sandeep. Thank you, Wilson. We'll see you later.
Thank you. Bye. See you later. Bye.